Because we're having so much fun with this, we're going to find one more Taylor series. This one's actually a little bit interesting because this is a polynomial. So this is going to be intriguing to see what happens when we look at the coefficients. All right, so of course the 0th derivative is the same as the function itself, which is x cubed minus 10x squared plus 6. And we're interested in the value, the center of 3. So we're going to find f of 3, which if you like, it's the 0th derivative at 3. In other words, you haven't taken a derivative. So that's 3 to the 3rd power minus 10 times 3 squared plus 6, which is negative 57. Because it's 27 minus 90 plus 6. So negative 57. Now we're going to take the first derivative, which would be 3x squared minus 20x. So that would be 27 again. Take away 60, so that would be negative 33. The second derivative of x would be 6x minus 20, which would be, let's see, 6 times 3, 18, take away 20 is negative 2. Third derivative would just be 6. No matter what value you had, in this case 3, it's still 6. And then the fourth derivative is 0. As a matter of fact, all the derivatives are from that point on 0 for k greater than or equal to 4. Okay? And same thing with this, right? So the fourth derivative is 0 no matter what. So that means that the kth derivative at 3 is 0 for k greater than or equal to 4. Now think about what this means. This means that our Taylor series is going to stop. It's not going to go to infinity. Our Taylor series sum will not go to infinity. Right? So when you think about from k equals 0, you're going to go from k equals 0 to k equals 3, it looks like. And then we'll stop because there's no point in going on past that, because the fourth derivative and so on are all zeros. Interesting. So this is very interesting. So polynomial has a kind of intriguing Taylor series that's finite. It's not infinite. So instead of going from 0 to infinity, we're going to go from 0 to 3. It's still going to be the kth derivative at 3 over k factorial times x minus 3 to the k. That's the general Taylor. Well, actually, if I'm going to say it's the general, then I put the infinity in there, but I'm going to take it out in another second. So the general Taylor series formula. All right. So then we are going to stop. So we're actually going to only, well, let me write it out. I mean, we don't even have that many terms. So it's f of 3 times, well, if you want, it's over 0 factorial times x minus 3 to the 0. So that's going to go away. Plus f prime of 3 over 1 factorial times x minus 3 to the 1, plus f double prime of 3 over 2 factorial times x minus 3 to the 2. Last term will be the third derivative at 3 over 3 factorial times x minus 3 to the third plus 0, right, from then on. All right, and I guess I'm just going to make a note right here. We're going to stop at 3, right? All right, so we're not going to go to infinity. All right, so this is negative 57, right? That's all that is, that whole term, negative 57. Plus, and then, oh, actually minus, because it was negative 33, right? It's up above. And so negative 33, 1 factorial is 1, so times x minus 3, minus 2 over 2 factorial times x minus 3 squared plus 6 over 3 factorial times x minus 3 cubed. And there are no other terms. Well, this is going to work out. 2 and 2 factorial are the same, and 6 and 3 factorial are the same, because that's 3 times 2. So that's all gone. And so that means that this function, or this polynomial, x cubed minus 10x squared plus 6 is equal to negative 57 minus 33 times x minus 3 minus x minus 3 squared plus x minus 3 cubed. And there's no need to work on the interval of convergence on this one. We actually know what it has to be. It has to be negative infinity to infinity, because this isn't really, they're the same function, right? This is like if I FOILed everything out over here, I would have that, right? If I FOILed everything out and combined like terms. So this is happening because the two functions are equal. They're both finite. They're not, it's not an infinite series. It's not, the Taylor series is not infinite. So there's nothing to fuss about, right? We know they're the same. It's kind of a very simple Taylor series. They're kind of fun though. Polynomials will always do this, because polynomials will eventually have derivatives of 0 all the way down. So you just have to break down. So because this was a cubic, that's why we end up with an x minus 3 cubed, right? If it was a 4th degree, you would have a 4th term over here. X minus 3 to the 4th, I should say.